In section 6.3, we're going to discuss the connection between free energy and equilibrium. Free energy, or delta G, is the amount of available energy, and K, our equilibrium constant, tells us the extent to which any equilibrium occurs. Favored. Thermodynamically favored, again, means 1, that delta G is negative. There is excess free energy by the system given off to the surroundings, given off to the universe. When delta G is negative, the free energy is given off, and that means that it is thermodynamically favored. Again, when we're reactions going left to right as we write them, going from reactants to products, and so that reaction being thermodynamic favors the products, and that would be thermodynamically favored. Where R is equal to 8.314 joules per Kelvin mole. You don't need to memorize this equation, but you do need to G, and you're solving for the equilibrium constant, or vice versa. One thing to point out here, let's make sure that goes away. Okay, let's try that again. The delta G is in joules. So we've got a little bit of unit conversion we need to worry about, but you'll see that in the example. We'll do it in a minute here. So, for example, if delta G is near 0, then K will be close to 1. And when we think about delta G being very negative, if it's very negative, a lot of excess energy is favored. That means that it's going to create a lot of product. It favors the products of the forward direction. And K that would favor the reactants. And K will likely be less than 1 in those situations. And the entropy change. Just a reminder from 6.2, delta G is related to delta H. The enthalpy is negative 58.03 kilojoules. The temperature in Kelvin is H is in kilojoules. And in this equation, we can't take kilojoules and subtract a joules. So we need to make 3 places and make that negative 0.1776 kilojoules per Kelvin. Now our Kelvin units will equilibrium constant using the second equation. Delta G is equal to kilojoules. We want to make sure we have converted the R value to reflect that also, or you could convert your joule. That equals negative 0.008314 times 298 times the natural log of K. And so, and then to get rid of the natural log, you raise it each to e to that power. And that's equal to e to the 2.06 power, which gives you a value of 7.085.